Pressure. It is a common experience that to apply force on an object, there must be contact between the two forces. Before we discuss about pressure, let us see how the effect of force applied by one object on another object depends on the area of contact between the two objects. Let us find this out by performing an activity. Take a wooden crate and fill it with mud, a mixture of clay and water, up to a height of about 30 centimeters. Take a brick and measure its dimensions using a ruler. Record these measurements. Length of the brick, L is equal to 25 centimeters. Breadth of the brick, B is equal to 15 centimeters. Height of the brick, H is equal to 10 centimeters. Place this brick horizontally on the mud such that the face measuring 25 centimeters into 15 centimeters is in contact with the mud. After a few minutes, remove the brick and keep it aside. Observe the imprint which the brick has left on the mud. Label it as A1. Now, measure the depth of the imprint with a ruler. Mark this reading by putting a red mark on the ruler. Pick the same brick again and place it vertically on the mud, a little away from the previous imprint, such that the face measuring 15 centimeters into 10 centimeters is touching the mud. After some time, remove the brick and keep it aside. Observe the imprint, label it as A2, and measure its depth with a ruler. Mark this reading with a blue pen. Compare the readings marked on the ruler. What do you notice? The brick sinks more when placed vertically. Is there any other factor responsible for this? Well, it is the surface area of the imprints which makes them different. The area of the imprint A1 can be calculated as 25 centimeters into 15 centimeters, that is 375 centimeters squared. Similarly, the area of the imprint A2 will be 15 centimeters into 10 centimeters, that is 150 centimeters squared. This shows that the area on which the brick rests in the vertical position is lesser, but the force with which it pushes the mud is greater. That is why the brick sinks more in the mud when placed vertically. We can thus infer that the effect of force produced in an object depends on the surface area of the object on which the force is acting. Greater the surface area, lesser is the effect produced by the force. Concept of pressure. The word pressure must be very familiar to you. In fact, we often refer to pressure in our day-to-day tasks like using a pressure cooker, hammering an ironing wheel, typing on a keyboard, drinking cold drink using a straw, pressing a pen on a board, etc. But what is pressure? Pressure is a result of force exerted over an area. It is the amount of force that presses on a certain area. We have seen earlier that the effect of force acting on a surface depends on two factors: the magnitude of force and the area on which the force is acting. This effect is measured as pressure. Pressure is defined as a force acting on a unit area of a surface in a direction perpendicular to it. Mathematically, pressure is equal to force upon area. Let us study the unit used to measure pressure. Since the unit of force is Newton and area is measured in meters square, pressure is measured in Newton per square meter, denoted as N per M squared. However, Newton per meter squared is known as Pascal, which is denoted as PA. Therefore, 1 Newton per meter squared is equal to 1 Pascal. What happens when surface area increases, but the magnitude of force acting on the area remains the same? To answer this, let us assume that you apply a force of 50 newtons on a 2 meter square area. Then, pressure is equal to 50 newtons upon 2 meters square, which is equal to 25 newtons per meter square. Now, if the same force is applied to 5 meter square area, pressure is given by pressure is equal to 50 newtons per 5 meter square, which is equal to 10 newtons per meter square. We can thus infer that by increasing the surface area, pressure increases and vice versa, provided the magnitude of the force applied remains the same. Let us perform an activity to understand this further. Take 2 identical iron nails. Place one of the nails with its sharp end pointing towards the wall. Try to hammer it into the wall. Now, take the other nail and try to hammer it with its flat end facing the wall. Could you do it? No, you couldn't. What could be the reason? Well, the force exerted on both the nails is the same. However, the area of contact between the wall and the pointed end of the nail is very small as compared to that between the wall and the flat end of the nail. Hence, pressure exerted on the surface of the wall is small when the nail enters the wall through its sharp pointed end. As a result, the nail pierces in the wall easily. We can thus say that when a force is acting over a large area, it produces small pressure, and when a force is concentrated onto a smaller area, it produces greater pressure. Just glance at your surroundings and locate examples where concept of pressure is put to use. You may start with a knife, used to chop or cut vegetables. Knives, blades, and other devices like scissors and needles have sharp edges or pointed tips. This makes chopping, cutting, and stitching easy as the area of contact is less. This produces greater pressure and makes our work easier. Have you ever thought why skyboards used to glide over ice are long and broad? The skyboards are made long and broad so that the area of contact is increased. We know that greater the surface area, lesser is the pressure produced. This makes it easier to slide over ice. It is for the same reason that school bags have broad shoulder straps. The broad straps distribute the heavy weight of the bag over a large surface area on the shoulders and thus reduces the pressure on the shoulders of the students considerably and makes it easier for them to carry such heavy bags. Do you know why porters place the load they have to carry on the roll of cloth rather than directly on their head? Well, the roll of cloth provides a broader base and increases the area of contact of the load with their head and thus reduces the pressure on their head and they feel less strain while carrying the load. Let us do a quick check. Effects of pressure in fluids. flowing substances and a compound called fluids. Let us find out if fluids also exert pressure, and if the pressure exerted by them also depends on the area on which the force acts. To find the answer, we shall perform an interesting activity. Fix a cylindrical glass tube about 1 centimeter long near the bottom of a plastic bottle. This can be done by slightly heating one end of the glass tube and then wetly inserting it near the bottom of the bottle. Seal it with molten wax to ensure that the water does not leak from the joint. Fit a rubber balloon over the mouth of the glass tube. Half fill the bottle with water. Note that as water is poured into the bottle, the balloon fixed to the glass tube begins to bulge up gradually. You will observe that the bulge in the rubber balloon increases as more water is poured. The balloon bulges out because the water column in the bottle exerts pressure on the walls of the container. Now, you will observe that as more water is poured into the bottle, the level of water rises. As a result, the force exerted by the column of water increases, and so does the pressure. It is important to note that the area on which the weight of water acts remains the same. We often see fountains of water coming out of the leaking joints or holes in pipes supplying water. It is due to the pressure exerted by water on the walls of the pipes. We can, therefore, conclude that fluids exert pressure which depends on the magnitude of force and the area of cross-section on which the force acts. Properties of fluids. Fluids enclosed in a container exerts equal pressure in all directions. When we blow air into a balloon, it gets inflated. As we keep blowing air into the balloon, it bursts after a certain size is reached. This happens because the air in the balloon exerts pressure on the walls of the balloon. When this pressure becomes large enough, the balloon bursts. You might have seen different shapes of balloons at the balloon window shop. When a balloon is filled with air, it acquires its characteristic shape, round or oval. Similarly, when air is filled in a bicycle tube, it retains its shape. This is because air exerts pressure in all directions, and this helps the objects to maintain their original uniform shape. Fluids flow from a region of higher pressure to a lower pressure. Now, let us understand an important property of fluids. For this, we need to perform an activity. Take two plastic bottles marked A and B, such that they are joined near the base by means of a rubber tube, which can be closed with a clamp. Keeping the tube closed with a clamp, fill bottle A completely with water and bottle B just a little above the rubber tube. Note the level of water into the two bottles. You will observe that when the clamp is set loose, water flows from bottle A into bottle B till the level of water in both the bottles becomes equal. This is due to the fact that water flows from a higher level to a lower level. You may now wonder, how is this related to pressure? Well, we have just learned that if the height of the water column is more, it exerts a greater pressure. That is, higher the level of water, greater is the pressure in that region. Hence, the water flows from a region of higher pressure in bottle A to a region of lower pressure in bottle B. Similarly, when the valve of an LPG gas cylinder is opened, the gas flows out into the pipe because the gas is stored under higher pressure in the cylinder. Let us do a quick check. Liquid pressure. Liquids like water, oil, alcohol, petrol, etc. possess this weight, and so they exert pressure on the base of the container in which they are stored. That is why when we pour liquid in a container, the weight of the liquid exerts pressure on the base of the container. This pushes the liquid down to the base of the container. The pressure exerted by liquids is given by the formula pressure is equal to force divided by the area. But in the case of liquids, force is the weight of the liquid and area is the area of the base of the container in which the liquid is kept. Let us perform an activity to understand the dependence of liquid pressure on land. Take 3 plastic bottles of different sizes and different diameters and mark them as 1, 2 and 3. On bottle 1, make 3 holes at the same height. On bottle 2 and 3, make 3 holes of different height and close all the holes of the bottle with tape. Fill the bottles with water. Remove the tapes from bottle 1. Observe the flow of water from the holes. What do you observe? You will observe water coming out of the holes and falling at the same distance from the bottle. This is because liquid force at height is same at all points of that level. Hence, liquid comes out with same force from the 3 holes of bottle 1. Now, remove the tape from bottle 2. Observe the flow of liquid from different holes at the same time. What difference do you observe? Now, the water coming out from the lower holes falls at a larger distance from the bottle. This is because the pressure inside the liquid at a point depends on the depth of the point. Similarly, observe the flow of liquid from different holes of bottle 3. The liquid pressure at a point depends on the depth of the container. It is independent of the shape of the bottle. Hence, the water falls at same distance as in case 2. Like gases, liquids also exert pressure. Liquids exert pressure on bodies immersed in it. At a point in the liquid, the pressure is same in all directions. The pressure at any point under the liquid is due to the weight of the liquid column above that point. A swimmer can experience the change in pressure as he dives deeper in the water. During swimming, the weight of the body is supported by water because of the high liquid pressure on the lower surface of the body compared to the pressure on the upper surface. If this difference in pressure is more than the weight of the body floats, else the body sinks in the liquid. Hence, it is clear that at a given depth, pressure remains the same in all directions. Pressure is independent of size and shape of the container, but it depends on the height or depth of the liquid. Pressure increases with depth. It also depends on the density of liquid. It is